Okay, so, yes, my name is Kresten. I'm CTO in Humio. And I've been working on this project for the last year that I'll talk something about today. And actually this presentation here is in 3 pieces. First I'll talk a little bit about why we're building this and what the idea is. And then I think by then the food will be here. And then you'll all be eager to get up and walk around, and I'm also starting to get hungry. So we'll take a little break. And then I have a short demo of the system that we built. And then after that, we have Richard from Spantry. He actually tried using this system that he'll talk a little bit about. So all in all, we prepared like probably close to an hour of talking on this. And I know with food and everything, maybe we should squeeze in. I'll try to do it a little fast. Anyway, so me, I have just a single slide about me, just to set some context. I'm Kresten, Dr. Krab at Twitter. I started out my career at Next, doing the Objective-C runtime system and foundation libraries and stuff back in the first half of 90s. Then I moved back from California back to Denmark, where I live now. I co-founded a consulting shop called Trifork 20 years ago, and I've been CTO for that for many years, for the last 20 years. We're about 450 people now, mostly across Europe, very much the same profile as ThoughtWorks, and we've collaborated on many occasions, most notably about GOTOs, because the GOTO conference is actually kind of started as our own internal continuous education program. And we couldn't afford to send all our employees to go hear Martin Fowler in London or the US, so we just invited him to come to our conference instead. Then all along the way, I've been like the go-to guy or the technical guy, kind of doing internal consulting and helping all kinds of projects. I spent a good deal of years doing Erlang stuff. I wrote an Erlang VM in Java, a JIT Erlang VM in Java. And the last year, I've been taking a leave of absence from Trifork doing this startup. And now we're a team of 6. At this point, Gita is actually one of them. She's my CEO. I better do what she says. So we're a year into this project here today. So much about that, about my background, right? So it used to be that we could really feel our computers, right? 40 years ago, this is what 40 years ago, this is what a computer looked like. This was the Gear computer. It was actually in the basement of my computer science lab where I studied. A big physical thing where, you know, as it was running, you could feel it. You could really feel the hum of it. And likewise, when I studied, I had a big fat desktop computer that would hum away. You could hear the spinning disks. You could hear there was this interference between the network card and the disk, so you could hear, and the sound card, the network card and the sound card. You remember that? There was that faint sound when there was network activity. You could hear it in the sound, and you could really feel the system. And it's kind of there used to be all these stories of, you know, there were engineers that the operators of this, they could hear the carry bit, or they could sense the system if something was wrong, if it didn't sound right. And we really lost that capability today in our systems of feeling the systems. It's kind of, I don't know if you've tried to been on like a big boat on the ocean, on a cruise ship maybe, and then all of a sudden the engine stops. You know, you didn't really sense it until it stopped. You didn't realize it was there. The hum was there, but all of a sudden something's really odd when it's not there. And there's all these subtle signals, this noise coming from the system that is part of this notion of normal. that the premise here is that we're kind of missing that today. We're missing that noise in the system, right? Because this is the way we have a nice tranquil office like here, and ThoughtWorks excellent offices here on the 25th floor, but the computers, they're down below somewhere. If you're lucky, they're in the basement here. They're probably in a data center somewhere up in Seattle. So you really can't feel it. We're completely disconnected from this hum, and thanks God, because it's actually pretty noisy. In my preparation, I actually found some sound, some data center sounds that we could play, and it's not particularly pleasant. But still, this notion of feeling the system, feeling the pulse, feeling the hum of the engine of the system is really missing in many ways. So in other engineering disciplines, when you need to get this feel for what's going on when something is very far away, you set up an operations center, right? So if you're sending a rocket to the moon, you have an operations center like this, and a very important part of this is, these guys in the rocket are far away, but these screens show information about how things are going, and they've practiced this many times, so they know what it's supposed to look like, what is the normal. And there's so much, not artificial intelligence, but just normal intelligence that you can apply when you just have these pictures and look at them. And actually in our development offices, TriForce development offices, we always have these dashboards and screens. Actually, all the development teams have big screen TVs where they can put dashboards up and get some notion of what's normal. So there's a big difference between having these various displays as a separate tab or as some URL that you can open and look at, and actually having it there as part of your daily life. Every morning, you're still sleeping and you walk into the office and just check, does this look like it usually looks? Yeah, that's fine. I'll go, oops, what was that? The ship's engine stopped humming. Maybe the graph dropped. Maybe the patterns are slightly different. And that's a good starting point to just go explore and figure out why isn't it normal? It might not be anything special, but there's an intelligence there that we can apply that's super easy to get going. So we really learned about this when about 10 years ago we built this big healthcare solution in Denmark, which is a centralized prescription drug administration system where all prescriptions that go from doctors to pharmacies go through our centralized system. And we have a whole bunch of different, there's hardware, so Denmark is a small country, so there's, maybe these numbers are not so impressive, but at least 40 different connected systems. So these are GP systems, hospital systems, pharmacy systems that need to integrate to this central storage, where we do auditing of policy. So you make, this is a place actually also where it gets checked that doctors don't prescribe drugs that they shouldn't prescribe too many times in a row to the same patients, etc. But it's also the kind of a vertical integration point across a range of different systems in the healthcare sector. It turns out if you know people's drug history, you know a lot about how they feel, what's good for them, and what's not good for them. So, but that's a completely different story. Very interesting domain. I spent a lot of time in this, but it was super important that this is highly available. Actually, it almost can't prescribe a drug today without the system running. It's been running 24/7 actually for the last 10 years. It's super high security, of course. You don't want to reveal this information beyond the systems that actually operate this. And there's lots of things involved, lots of things that can go wrong. And at this time, we started working with gathering log information and doing graphing over these systems. And we really we really learned this value of feeling the hum of the system, of having these dashboards, and now it's general practice that everybody should do that to get some notion of how is the system doing in production. So Trifork is maybe not a normal consulting shop. We do projects, right? We take ownership for our customers' bespoke systems. So it's not like a body shop where we go sit at a customer site. So taking that ownership, part of that is actually feeling the system and having an idea of that. So this is very important. I know I spent 10 minutes already talking about that. So what you get is some sense of normal. So it could be a graph like this. It just shows kind of a core level thing in a healthcare system. Could be how many drugs are prescribed over the course of a day. This could be what happens one day. This is what happens the next. And then, of course, you have a very visual and easy way to see if something is really amiss. Maybe some system ran while starting to do prescriptions, or typically when something goes wrong, it becomes lower. Or if you graph the number of errors happening, if you just graph how many errors are happening, that's a very simple graph to do. If it looks different than normal, or different from yesterday, or different from last week. So when you work with this, when you work with this extensively, you end up thinking of logs as a first-class citizen. It's not just a byproduct of running the system. It's a part of the system. And there's a mentality shift. It's kind of moving from before we had test-first programming, and now we do test-first programming. Before, you didn't imagine how profound the difference it would be. Same with continuous integration, right? Before we started doing continuous integration, we could easily start projects without having a continuous integration server and a build pipeline and everything set up. But now we almost can't fathom that. When you start working seriously with logs, you wonder, how could I live without this before? If you've been through that transition with test-first programming or continuous integration, introducing that in your organization or projects, I can only say it kind of feels the same way going from before actually working actively with your logs to after, because it's like an enlightenment. Wow! All of a sudden, I can feel my system, and of course, it's not feeling the system like physically, but you get new ways of interacting and understanding your system. So there's tons of things you can do with logs, and in the next 5 minutes, I'll just run briefly over a few of them. You can observe and monitor, as you already talked about. And actually, a very, very simple thing to do is just to do a graph of the number of log entries. You don't need any fancy parsing or cool indexing features. Right? Just see how many logs are there. Maybe you select a grep for some of them, and then graph that. Like I said before, you want to show a graph of how many errors are in the system. That could be as simple as give me a graph of how many log lines match the string error, because it still gives you an idea. So you can use logs to observe and monitor, and I know typically, these years there's a lot of metric systems, and lots of people use specific metrics and encode metrics into the systems and send them to a metric server of sorts, Graphite or whatnot. But the case with logs is that they're already there, and often you can just extract, count, or something simple like that. Find the events that you want to observe, and it becomes a super low friction way for developers to put information into the logs that then we can easily extract, as opposed to having a specific metric system where you need the likes of a DBA to set up the schema for those numbers that needs to be collected, and somebody else to go design a graph that then gets shown somewhere and maybe somebody uses it. We want to, with logs, any developer can emit an extra log, and any developer can go and grep through the logs. And when you add those up, you get a very, very easy to observe and monitor kind of notion. You can use it to understand and debug your systems. So if something goes wrong, we used to go to tailf grep things in our logs, but as we get more and more servers, that gets increasingly difficult to do in practice. But when something goes wrong, it's nice to have the logs. And it's nice that this is connected directly to the graphs and the dashboards that you see. We also use it to make projections or find trends. So in the healthcare system, for instance, because it's an in-production system, it's been running there for 10 years. You need to figure out when do we need to add more machines or add more storage, or is it at capacity, or what percentage of capacity are we? So actually project what's going to go on. You can use your logs for that to see how's the load going, how is the storage, whatnot. You can also use it, of course, to dig through old problems. So it's very text log files are they're easy to compress, so you can store lots of them. So if you have a system that lets you store and archive log files in an easy and accessible way, you can store them for a very long time. And you can go back and say, this happened last year or last month, and extract information out of them. It's often that when something weird happens, you didn't actually capture the information that you needed. So often you have to go look for special patterns in your log files or special things, and you definitely didn't extract it and index it and store it in a database that this bad thing happened. You can use it for testing and validation for systems integration. The nice thing about logs is that you can use logs from systems that you don't control. You don't need to write your own logs. You can use the logs of Nginx or of MySQL or of other systems where you don't control the logging format. So it's really relatively easy to write a test that captures the logs and then run a validation test over it. The logs should look like this. We should have these patterns happening. This many times this should have happened. This many times this should have happened. And in terms of the healthcare system also, the interaction between developers and operations, this was a super isolated system. So developers were really separated from the operations, but developers were permitted to go actually look in the logs. So you get a nice read-only way to look into the production world, which is otherwise heavily shielded, and with an audit log on what the developers do, what queries do they make, and a system where you have to describe why did I go in there today and look in these logs. You actually have an audit record of and a really nice way to interact with the system, even in a high security production environment. We also often find ourselves using the logs to do prototyping of new features, do kind of ad hoc intelligence. So it often happens that the users will come and ask a question that the system doesn't have features or screens or functions to compute, but the information is still there in the log. So again, in the healthcare system, there's lots of variations over different audit profile tests. So how often does it happen that a doctor has a session with a user where he requests his user's prescription profile, but he does not issue a new prescription? Or this information can maybe be extracted from the logs, from the audit logs. So there's lots of different things you can do with this, and it's super easy to interact with this text. So this all sounds pretty. This should be easy, right? So there's a few design space slides I have. So one thing is you want this to be interactive. You want this not to be batch-like. Sometimes. So and with interactive, I say I'm meaning I want this to feel like Excel, the same way like an Excel spreadsheet. If you, the way you're sitting there playing with it, it's interactive, and you can try out different graphs and do a little report. That lets you do like iterate or explore on what you can extract from the data, how you want to work with it, and how you want to understand it. Because that's an important aspect. Often you see these systems being very batch-like, where somebody has to go write a batch script and run that on those log files that are stored on S3 that you then maybe can run. If you need to change it, you need to get hold of the developers that can write that Scala that goes into that pipeline system that can compute the new numbers, right? Which could be days or weeks to get a new report. You want something that can do some kind of ad hoc report. There's also both being able to process live as well as historic data. So once you get the flu, once you get this beast, you're not happy with only looking at historic data. You also want to be able to do this in a stream processing way on data as it comes in the same ad hoc-y feeling like Excel way. And of course, the big one is you don't want to be limited to a schema that's defined up front. So many systems in this world, you need a schema when the logs enter, when you save the logs. Right? So you discard the text and just save whatever is indexed, and that's of course the normal nature of a database. But it's really nice if you could do schema and read, and when you process the data, when you ask the question and say, I'm really interested in extracting this information and this information. I don't know how often I've been in this situation where you think, I wish I indexed that. I wish I also saved that information in my database. So if the foundation for this is text, you can just go read it again and extract it again. So a system that lets you iterate, explore, and visualize your logs, and that's not only that, it's accessible to everyone. Everyone should do this. It's been an enlightenment to been through these last 10 years of working with logs, looking around, and we're not really happy with all those systems out there. Of course, that's what we've been doing, and we really try to provide this fast and flexible, affordable, simple to use feel, and that's what Humio is. So that was hopefully a teaser for a demo.